This is my turbulence fluid dynamics tutorial for making an explosion similar to this one. So let's hop on the light wave and get started. There are two ways to use turbulence. The first way is getting like a particle emitter or something. So you just have it emit like that, and then you'd use fluids. I actually don't like that very much. I know some people prefer to do this. I would prefer to do it because I like to use particles a lot more, but I've just never been able to get a good result from it. So let's just make a new fluid container here. I'm going to make this 10 meters. I'm going to make this 8 meters by 8 meters by 8 meters, offset it by 4. You know the drill. And let's bring in a particle emitter here. 2 meters per second. Yeah, something like that. Okay. And then we're going to make this an emitter. Okay. We want to set our particle radius to something like, I don't know. Let's set it to 10 millimeters, and then we'll add some pressure here. We'll add like 16. And what this pressure thing does is it makes the particles bigger. It adds outward pressure to all the particles. And then let's set our temperature to 1, just to get like a basic simulation here going. All right, so let's also make a cache directory here. Okay, and let's start. So this isn't a super great simulation here, but you can start to see why I don't really like particles. And the reason why I don't like particles is, first of all, until the particles decay, it actually follows them, and then after that it starts to do the fluid stuff, like you've got this little mushroom cloud thing going. I don't really like that. And you know, you can increase the size of the emitter here. So I've just never been able to get a really good result out of particles. If you can, then you know, more power to you. Maybe you can contact me telling me how you're able to do that. But I just can't. So yeah. Anyway, beyond that, let's go ahead and delete this, and I will show you how I make explosions. So let's start out with the sphere. I'm actually gonna go back to Modeler and open this back up in Modeler. So I like to, with my emitter objects, I like to add a little bit of disturbance. I like to disturb the geometry a bit with a jitter, and set this to like 0.05, something really small. That's actually too much. 0.01 maybe. That's still a bit too much. Let's set to 5 millimeters. There we go. All right, this is what we want. All right, so this is kind of jagged and stuff. So when it's emitting out of the surface normals, it's not going to be this, you know, uniform distribution. It's going to be a little more chaotic than that. And we can make this more chaotic, first of all, by making it an emitter. And we can go to our texture here, and let's set our texture scale to 200 millimeters. So that's about the size of the ball here. Let's bring our contrast up to 1.5 and bring the octaves up to 2. All right, and then that's going to add a little bit more. What it's going to do is it puts a texture on our object here, and then it only emits out of those parts of the texture. So beyond that, what we're going to do is we're going to go to simulation here, and we're going to turn density, fuel, and burn. We're going to turn all these guys on, and we're going to have this emitter emit out of the fuel tab, or fuel channel. And the reason why I do this is you emit fuel, and the fuel burns into the burn channel, and then it also emits temperature and density. So it emits all of the other channels from one channel, and I just get really good results from it. So let's start this up. So what I want to do is I want to emit, like, say 2 for fuel, and then I want to, after 2 frames, I want to bring it down to 0. All right, and let's just run a simulation there to see where we are. So this is not very impressive, but as you can see, we have data in. Do we? No, we don't. Oh, forgot to turn caching on for all the other stuff. Oops. So I'm just gonna delete this cache. Make sure I have density emission and temperature emission turned on and burn rate turned on. Let's try this again. So this should give us what we want. Yeah, so if we go to viewport preview, you can see that we have data for density, temperature, and a little bit of data for burn. Not very much, because it dies out really quickly. So next thing I'm going to do is I'm going to set this to something way higher, like 5. And we're going to play around with these parameters a bit. First thing I want to do is I want to set my expansion something like 2 and see what that does. I'm also going to increase my let me clear my cache real quick. I'm also going to increase my temperature and density emission something like 2 to set my burn rate to 2, set everything a lot higher, and see what that does. So now you can start to see that this is getting a bit bigger. And we haven't added any pressure, any parameters like that yet, even. So this is sort of like, I don't know, flash paper or something. Really, really small wisp of smoke. Maybe like, you know, one of those guns that they have where it fires a little puff of smoke. Those are cool. I had one of those, but then it broke. That was a sad day. So after that, what we're going to do is we're going to add some pressure. I'm not going to use normal force because when I'm using a sphere emitter, normal force never works for me. Once again, if it works for you, then more power to you. Send me a message telling me how it works for you and how I'm stupid that I'm not able to do it. But beyond that, we're going to set our pressure to 64. Now you want to also animate this parameter too, because if you don't, then it's going to keep blowing out on your fluid and you're just going to get really weird results. So make sure if you're doing something like an explosion, all of these values you're animating them. All right. So let's resim, and we should get something bigger. Now, sort of like the cheater's solution, if you're making an explosion, is to take this radius value and set it to something higher, like say 100 millimeters. I don't like to do this. It makes it bigger. I don't like to do that because that's not actually... You're not actually adding more force to the explosion. You're just making like the initial particle size bigger. So I don't like to do that, but you can if you want to. If you're a scrub. Let's have the pressure animate over a longer period of time. Let's actually bring this up to say 10 frames. And then we're going to take our TCB line and we're going to set the tension to 1 so that it sort of has this sharp drop off here. It's sort of like an S-curve sort of deal. Let's see what this looks like. So you see that because the pressure lasts longer, it spends more time expanding over here, this earlier part of the frame. So then the resulting thing is bigger. All right. Okay. So now a couple of things I want to do. I want to take my density here. I'm going to add some gravity to it. I'm going to set this to an initial value of 100 millimeters. And then one more thing I'm going to do is I'm going to take my pressure and I'm going to so this is kind of like an S-curve, this pattern here. Okay. And I'm going to double this. I think a value of 128 usually gives me the sort of results that I want, but I like to bring it up gradually. So let's try this again. So once again, our initial explosion is even bigger. So at this point, let's actually decide how big we want this to be and what we want it to look like, and we can go from there. So this explosion that I had before, it sort of stayed closer to the ground. It didn't have as much of a mushroom cloud effect as what you generally see from typical fluid dynamic simulations. I still have these EXR renders, so I'm going to actually go for something different this time around. I want there to be a lot more of a pronounced mushroom billowing, but I still want to keep some like dust and stuff on the ground like you see here. This is kind of what I consider to be the mark of a good fluid dynamic simulation, which is where you've got some leftover smoke on the ground here. It also gives your simulation sort of a sense of scale too. Yeah, so let's get started. First thing we're gonna do is we're gonna move our camera. So we wanna take our camera here, and oops, didn't mean to do that. And let's move it to where we want it to go. So I want the camera to be parallel to the z-axis here. All right. Let's move it back a bit. And we're gonna add some wind to this, but for now, this is a pretty good place for it to be. So I do want this. There are a couple of things I want here. First thing I want this initial blast to be much bigger, and then the second thing I want is I don't want the entire fluid to rise like this so quickly. And adding gravity will help with that, because what's going to happen here is I'm going to make this so that the temperature, which causes the buoyancy, I'm going to make it so that that decays faster than the density does. So as the fluid starts to cool down, it's going to stop being buoyant. It's just going to hang in the air. So let's just do a simulation with gravity turned on and see what that looks like. Looks really similar. I think I might have already done this, and that's why it looks so similar. So here's what I'm going to do. I'm going to take my temperature, and I'm going to leave the half-life where it is, but I'm going to take my density, and I'm going to set the half-life to 80 frames, so something much lower. All right. And then I'm also going to take my density emission and bring it up. So let's see what that looks like. Use my GPU. So here we're left with a really interesting effect. as you can see, the explosion sort of goes up, and this inner part kind of stays. We don't really want it to be that drastic though, so I'm gonna turn up my temperature decay time to like 50 frames, and I'm also gonna expand my slider to 240 frames. So if you have used TFD or done really any sort of CUDA computing for that matter, you should know that it's not a good idea to use the same GPU that you use to drive your display for computing. That's a really bad idea, but I'm going to do it anyway. But I'm going to be very careful when I do it because I run a really, really high risk of crashing my machine when I do this. So I'm going to watch my memory here, and then once it starts to fill up my GPU memory, then I switch back to the CPU really quickly. But you can see how much quicker it is. Alright, so let's turn on our density again, and once again we get this weird thing where it's sort of staying there. That's really weird. And I suspect the reason for that is because I have my gravity set too high. So I'm going to go back and I'm going to turn both my buoyancy and my gravity down. So I'm going to bring the buoyancy down to like, say, 150 because I don't want it to rise up this much. I'm also going to turn my gravity down to like, say, 60 millimeters. Okay. And the other thing I'm going to do is I'm going to take my pressure parameter and I'm going to bring this out to 20 frames, double it, see what that looks like. And then I'm also going to take fuel and I'm going to have it emit for longer. I'm going to have it emit for 5 frames as opposed to only 2. And let's start this over. So right away we can see that this explosion is about the size that we want. And I'm simulating at a pretty low resolution right now. I'm only simulating at 20 millimeters, which is pretty low for the size of the container I have. But I think that this looks decent, I think. So let's go ahead and start adding some more parameters here. The first thing we're going to do is we're going to add some wind. So I'm going to move this emitter over here. I'm going to have my wind be on the positive x-axis. And I'm going to set it to 100 millimeters. And let's see. Not 100 meters. Oh, no. 100 millimeters. Let's see what this looks like. Looks decent, but I want it to be a bit stronger. So I'm going to double the wind speed. So this is really interesting. We're noticing now what's happening is the explosion forms, and then the temperature cools, and it takes away the buoyancy that it had, and the density causes it to actually come back down, which is really, I've actually never had that happen before. So I'm going to go to the density here, and I'm going to actually make it last a lot less long. I'm going to bring it down to 60 frames. And that should help with that. And then the final thing I do before I go into start playing with the vorticity is I'm going to close my negative Y boundary. And what that does is unless you check this box, it just deletes any information that intersects with this boundary here instead of treating it like a collision object. And we're pretending that this is the ground that the thing is exploding off of. So because we're doing that, it's going to treat this like a collision object, and it's going to be a lot more realistic. So let's go ahead and resim. And you'll notice that it's actually interacting with the ground as opposed to just deleting all the particle voxel information that intersects with it. Now, one thing that I wish there was I wish that there was some sort of tab where you can control how much a particle like cools when it comes into contact with a collision object. Because what I like to see is that a lot of this stuff at the bottom, it comes into contact with the ground and immediately cools a lot more than the stuff up here. So you have a lot more density that's left down here. Let's look at our other, got temperature, got burn. Isn't very much burn going on here. So I'm going to have to fix I don't know when recording stopped, but I've just made a couple of tweaks here. So the first thing I did is I took the fuel emission and I brought it out to 15 frames. So basically it's emitting for up to half a second before it stops. And then that helps give it a little bit more of a tail. And I cleared my cache too. And then the other thing that I did, what else did I do? I think that's the only other thing. Oh yeah. Other thing I did was I took burn. I changed the decay mode to exponential and set the half-life to 60, so it'll last a lot longer. So let's see what this looks like when we run a simulation. So you can see that the initial blast is much bigger now. I also took the wind speed and brought it back down, so I didn't like how it was really fast. So one more thing we want to do right now is we want to change a couple of parameters here. Let's go to solver. We're going to change our frame and pressure substep and iteration limits to 2. What that does is, first thing it does is it gives us a little more accurate results here, and then the second thing it does is it lets us use motion blur. And I'm going to go to volumetrics and fog, fluid shader. I'm going to turn on use fluid motion blur. So now when we render, it's actually going to use motion blur, provided we have it turned on the camera here. So I'm going to go ahead and turn that on when we start to render stuff. Also, I'm going to change my velocity and channel advection accuracy to second order. The reason that I manually clear my cache every time is because when I don't do that, it's supposed to clear it when you rerun a simulation, but I've found that that does not actually work very well, for me at least. Also, another thing that people tend to not realize, let's make it so that you can't see this. The other thing that people tend to not realize is that you can actually change the shape of your emitter. So for example, if I stretch it like this, if I run my simulation again, turn my viewport preview off, because then I can use my GPU to simulate. Now you'll notice that it's incrementing by half frames here, because it's doing an extra simulation for each half frame, which will give you more accurate results. So you'll see once I stop this that this is actually going to look quite a bit different. I think it has something to do with the fact that we brought up our accuracy and also we brought up our substeps limit, but you can see that this shoots up a lot quicker, and that's because we changed the shape of our emitter. But I like to squash it a little bit, and so I'm going to squash it just a bit. Okay, clear my cache again, and let's see what this looks like. Only have 160 gigs or so to work with on my local disk, so I'm being really careful with my memory usage here, which is just good practice in general. So let's see what this looks like. Got a really big mushroom cloud here. So I kind of like how this looks. I would like it to not be so circular. So if we look at this from a top view, you can see that this is really circular, but instead of changing how our emitter works, can actually use turbulence to achieve the desired effect there. So that is actually the next thing we're going to look at is vorticity. So far we've been getting this really bland looking mushroom cloud here, and we are actually going to give this some character now. So the intensity channel, I'm going to set this to density, and I kind of ignored this parameter here until I actually realized what it does. Basically what it does is it maps the vorticity based on what the value is in you know, whatever channel you set it to. So for example, in density, basically what this is saying, if something's really dense, then there's going to be a lot of vorticity where it's going to amplify the smaller curls and stuff, and then that'll fall off once it starts to get cooler. So I'm going to set this initially to something like, say, 16. I don't know. And what I find vorticity does is it kind of gives the explosion sort of a sense of scale. So now you can see that there's a lot of smaller details here. Also, our voxel size is really big, so we might want to turn that down soon. Yeah, so you got a lot of smaller details here that you can't really see because of the fact that our voxel size is gigantic. So next thing we want to do is actually turn that down a bit. So I'm going to bring this down to 15 millimeters and see if this looks any better. Yeah. So I'm liking how this is looking. This is a lot different than the explosion I had in the example, but I like sort of the change of character here. And then if we look at the burn channel, stuff's going on there too. And we can go back and change this. In fact, I'm probably going to go back and change it at some point, but it looks good for now. So next I'm going to look at turbulence, and turbulence intensity, I tend to set this too low, so I kind of have to force myself to bring it up. I'm going to set it at 200 millimeters to begin with, and I kind of use the grid size here. The grid size is 200 millimeters, so each of these little squares is distance of 200 millimeters. I like to set the intensity channel to temperature and the vorticity channel to density. But you can, one thing that I can't stress enough is that every explosion you might want to do is different. Like right now I'm going for more of a poofy mushroom cloud sort of deal, but depending on what your application is, you're gonna want something else. So don't forget that. So feel free to play around with this stuff, because I'm not trying to imitate the example. So with that being said, set our smallest size to, say, I like to set it to a little smaller than about the same as the voxel size, maybe 20 millimeters, something like that. Largest size, let's say it's 400 millimeters, something like that. And then let's bring our small power up to something big, like 0.7, 0.6. Save. And let's see what this looks like. So one thing that I think is a bug, I'm not sure if it's intentional or not, I think it's a bug, is that even when you don't have update preview selected, when you're running a cache completely from scratch, you see you still see the simulation. So I actually have to turn off viewport preview, especially if I want to run my GPU. I definitely don't want to have viewport preview on if I'm running the GPU, because then it's trying to calculate that, and then it's also trying to calculate this, and you know, bad things happen. And then I bring it back to the CPU. Now I can see a lot of artifacts here. I think that possibly might have to do with the fact that I'm using my GPU to simulate this. I haven't actually run a test to see if that's the case, but I'm definitely going to use my CPU when I do like the final simulation here. So that's what this is starting to look like now. So let's take the turbulence and bring it up, because it's not actually really doing much for us right now. Let's bring it up to a meter, something crazy. So as you can see, it's a lot more lopsided now because the turbulence is affecting it. Now I actually, I don't animate the turbulence and vorticity intensity, and here's why. You've got your intensity mapping here, so it kind of animates it for you, because normally you'd want to like animate it so that it starts really high and then it goes down because you're You start, you know, with a lot of turbulence when the explosion starts, and then once it sort of is just a dust cloud, you don't have that anymore. But with intensity mapping, you can, you know, it does that for you, because once it gets to a smaller intensity, then it just stops. It stops being turbulent. I am a master of vocabulary and clear diction. So let's go ahead and do a test render, or just look at this in VPR. I'm gonna change my fire channel to burn, actually. Use density for my smoke channel. So you can't really tell what exactly is going on because these default settings are really bad. Let's turn our... Yeah. So I think this looks pretty good. One problem I have is that I don't like that there's not very much detail in the explosion. I think that's because the verticity is a bit too low. So I'm gonna like quadruple that. I think it's funny how in visual effects, when something's not quite the value you want, you kind of change it by a factor of 2 or 10. I don't know if anybody else does that, but I do that. It seems like so much of what you do is logarithmic in nature as opposed to linear. So while this is calculating, I'm probably gonna just cut this out because there's no point in you having to sit and wait while this calculates. When I was simulating the explosion, I noticed that there was a issue with the container. You know how there's an adaptive container here. This green box here is the actual container that the fluids are being simulated in, and it's the smallest that it can be to contain everything, so you don't have to simulate the entire contents of the container. But anyway, it was around frame 20 or so. It was getting to like the size of the entire container, and I couldn't figure out why. So I tried a bunch of stuff, but I decided to just go ahead and start from scratch. So I tried the best I could to imitate the result that we got, and so I made a couple of simulations here. So here's with turbulence. And it looks pretty good. So I think that this is cool, but a couple things I didn't like was I didn't like the turbulence getting a hold of this fluid over here and pushing it off to the side. And I also I don't like the shape of this cloud. So I decided to actually get rid of the turbulence, and this is what it looks like without turbulence. Very similar look, but I like how this looks a lot more. So I actually made 2 different caches, and I'm keeping the one that does not have turbulence. So I'm just going to show you some of my settings. I changed the radius to 50 millimeters. I'm not sure what it was before because I started from scratch. I brought the scale down to about 100 millimeters because I was noticing that the texture on the emitter was affecting the shape of the cloud because more than I wanted it to, because if you make it too big, then you get to where like only a small part of this of the emitter is actually emitting. In terms of force, I went to stepped envelopes, and I have pressure set to 64 that immediately drops to 0 at frame 5. And then I have the same thing for fuel, except it's at frame 2. So a couple of things that I noticed after doing this again that I actually didn't know about before. The first thing is fuel. This expansion value is actually really cool because as the fuel burns, it expands. So you can even sometimes get away with not using any pressure at all and just using this expansion value to get your explosion. The other thing, this compress cache button, this thing is amazing. All right, always have this thing checked. I was expecting it to maybe I don't know, reduce the size of the cache by like, I don't know, less than a factor of 2. I was very wrong. It almost reduces your cache sizes to by a factor of at most 10, at least 2. To the point where instead of talking about hundreds of gigabytes, you're talking about like tens of gigabytes, or in some cases even hundreds of megabytes, like if you're only doing one channel. So this button is amazing. I'm using the same settings here as we had before. One thing I changed, I don't have turbulence anymore, so I should probably turn that off. I think I brought the buoyancy for the temperature down a bit. And then I also upped the burn rate, expansion, temp, and density emission to try and replicate the results that we had. So I'm pretty happy with this simulation. I don't think we need to up res. So let's just go ahead and get to our render. All right, so this is simulated, and I decided just for the heck of it, I would go ahead and run an up res sim. So let me show you. This is the info file, hold on, for our regular cache that's compressed. All right, 20 gigs, that's pretty reasonable. And I did an up-res just for the hell of it. And close this stuff down. This is the size of the up-res file. So we've got a almost 10x increase with this up-res data, which is probably a lot less than if we actually ran a 4mm simulation. But I have run a couple of renders, and I decided that I think that the up-res is worth the sacrifice in having only 4 gigs available on my hard drive until I just, delete the cache once I'm done with this. So let's get to our render settings. First thing, we want our burn to be our fire setting, and we want density to be smoke. And I apologize that everything's so slow. Reason for that is because the one thing is that this is so detailed, and then the other thing is that there are only 4 gigs left on my hard drive. So once I'm done with this, I'm gonna have to just delete this cache because this is just ridiculous. This is probably like the largest folder on my hard drive right now. I don't have a very big hard drive. So anyway, first thing we're gonna look at is the fire, because so we're gonna go to our burn channel, shader, fire shader, and let's go to a frame about 20 frames in, about a second in. Okay, this looks pretty good. Let's set our channel to burn. This is what it's actually going to look like for you. I made a couple of adjustments. I tried to put it back to where it was before, but I forgot about that setting. But the opacity is at 1 on default, and this is good for like a candle flame or something. But for an explosion, you want a much more opaque fire. So I would recommend like 15 to 25. Let's try 20. And I would recommend playing with this opacity setting before you even touch these other settings, because usually you'll get pretty close to what you want just by changing the opacity. And a lot of times, you'll spend forever fiddling with the opacity setting, trying to get anything other than the opacity setting, all of these settings to get what you want, when really you just needed to change the opacity setting. And I actually forgot to do that with the example explosion. I kept the opacity at 1. It ended up looking really good, but I think it actually would have looked a lot better if I'd brought the opacity up. So bringing it up to 20, you can see that the fire is already a lot more realistic. All right. So we're going to make this look a little better. So the white point is basically the fluid intensity, where this is white. And then damping, I'm not sure what damping does. Damping kind of, it just kind of changes these parameters in a way where if it's lower, then it's going to be a lot, whiter, yellower, more intense. And then if you bring it up, like say to 15, it's going to be really orange and dull. So let's start in a value of like 8 or so. So that's still way too high. This thing is kind of finicky. So like it was at 5. So you can tell. I actually kind of like it at 5, to be honest. Let's play with the white point though. Let's try 1.5. I think this looks better. The thing to remember is don't try and overdo it. Oh, another thing. Let's look at the mapping. So if you'll notice, the default mapping is sort of this triangle here. If you look at a candle, I'm actually going to try and pull up a image of a candle. So if you look at a candle, you see that there is this space in front of the wick that's transparent, and then you've got the glow. So that's why stuff that's really, really hot, you're not actually going to see it. It's going to be transparent. And so let's actually look up Fireball. Let's look at some Fireball pictures. This is not what we want. But if you look at this, you can sort of see there's some transparency in the hot spots. So definitely you don't want to, for example, do this. It may, look good, but trust me, it's not what you want. And so I'd bring this over to like pass point to like 1.15 or so. Right. So this is the sort of color scheme we're looking for. And if you want it to be white in the beginning, which you definitely do, you can do all of that in post. Like your render, you need to keep in mind that your render straight out of Lightwave is not going to look nearly as good as once you bring it into After Effects and start color correcting it. So I kind of like how this looks. It didn't really take very much finicking to get to what we wanted. I would like there to be more red though, so I'm going to play with these values a little more. I want this red thing to be a little more prominent. So bring this down to 2. That is the opposite of what we want. So I'm actually going to bring the damping up to 7. And then I'm going to bring it down to 6. I'm going to try and bring the white point down to 0.8. So these two controls, they play off of each other. And you can combine them to get what you want. So I actually like this more. I think really what you're going for here, you don't want something that's, perfectly perfect and perfectly photorealistic. What you want is you want a good representation of all of the characteristics of your explosion, so that once you jump into After Effects and you start color correcting this, you're going to be able to dial in exactly what you want. You're not going to lose any color information. So I like this, and it doesn't have to be perfect. A couple of things I'm going to tweak. First thing I'm going to tweak is a lot of this stuff that we're seeing. This is going to be, handled with the smoke. This doesn't need to be visible, and I think it's more important to have the fire be visible. So I'm going to take this thing, I'm going to move it over just a little bit, just a tiny bit, and that clips some of our less bright parts of our explosion. So you see, as it starts to stop burning, Fireball starts to go away. And another way you can do this is you can bring this back really close to 0, and you can actually change the bias for this curve. This looks really good. And then you can increase the bias for this curve, so that when it's more explosive, you have a little bit thicker of a fireball. And like I said before, don't overdo this. You just want a little bit. So now let's move over to smoke. I think this is good. We're going to do some test renders once we take care of the smoke. All right. So just density smoke shader. I really don't like the defaults for the smoke. This is good for if you have like a really like explosion. I don't know. Yeah, I'm not sure what this would be for. I don't like this light smoke color. So what I do, I keep the brightness at 100. Well, there are two options. First, you can keep the brightness at 100 and you can make the smoke color really dark. Or, and you can see that makes it dark. Or you can bring the smoke color up and you can bring the brightness down to like 3. All right, similar effects. I like to do the former, brightness at 100, dark smoke color. And then we're going to bring this thickness way up to like 25 because we want really thick smoke. And then the final thing we're going to look at is multiple scattering. Multiple scattering is basically color global illumination or radiosity for smoke. And it just sends rays in and bounces them around. And just like radiosity, it takes a fucking age to render. So we can bring down a resolution here. I like to bring up the depth, bring down the resolution. The fall off, this max depth, if you don't want to bring this up too high to increase the render time, you can bring the fall off down to like 50. And then this illumination resolution, I'm also going to bring this down to 50. Basically, you want these settings to be as low as you can without seeing artifacts. Once you start to see artifacts, then you want to bring it back up. But until you see artifacts, you want to keep this as low as possible because you're not really going to gain anything by, you know, just cranking everything up. So let's find, I want to find a frame where the fire is starting to sort of die out, because then it's kind of hidden by the smoke and you can start to see the interplay between the smoke and the fire. One more thing, fire shader mapping. There's this option called clear smoke above. What this does is, right now it's at 1. That means that any part of the fluid that's over 1 intensity where there's fire, it's going to get rid of the smoke in front of it. So that just cleans up the render. So that's, if you're not quite getting what you want, like you have a lot of smoke covering the fire that you don't want to, or you want more smoke, that is a setting you can play with. So let's go ahead and do a test render. And if you didn't play with the global illumination settings, then you're going to find that multiple scattering takes much, much longer than it's going to take me, because when you bring those resolutions down, it really, really speeds stuff up. So it's going to take me probably about a minute to do multiple scattering for this. It'll probably take you more like 5 or 10 minutes if you, for the same system specs, if you don't optimize multiple scattering. And it's probably also taking me longer because, you know, I have 3 gigs left on my computer, which is not good practice. So I did not optimize my multiple scattering settings when I did the example explosion. And so I was rendering at 1080p and probably multiple scattering for each frame took something like 5 minutes. Okay, right now I'm rendering at 1440p, so 50% more resolution, and it looks like we're going to break 4 minutes here, hopefully. And this would take much, much, much longer if I didn't optimize my settings. And I'm going to probably optimize them further. Like I said, I'm going to bring them down. We're going to bring them down until we see artifacts, and then we're going to bring them back up. But this is just sort of a middle ground setting that you can set it to. Just to get a general idea of things. So the first pass is done. The second pass usually only takes like a couple of seconds. So it's about to start actually rendering the frame. And may God have mercy on your soul if you're like rendering this in a scene where you also have radiosity, that would not be good. I don't know actually if the turbulence fluids project brightness onto other objects if you're using radiosity. That would be an interesting thing to test. That's kind of beyond the scope of this tutorial, so I'm not gonna, try that. Feel free to try it yourself, though. That would be a interesting thing to find out. But I would even suggest, if there is such a setting, I would actually turn it off. And what I'd do is I'd render in multiple passes, and then I'd use some sort of point light or something for the light. Like if you have an explosion, like illuminate something, I would use a light for that, or not, because then the issue that you might have is you might have the light actually illuminating the explosion, so then bad things would happen. And all right, here is our multiple scattering render. Looks very nice, and even though we don't have any color correction on it or anything yet, it still looks really good. So the next thing to do is we're going to bring our multiple scattering settings way down. Okay, I'm going to bring my illumination resolution to 20, directional resolution. Let's just look at the illumination resolution first. So I'm going to keep this up and we're going to compare these two. See how much faster multiple scattering is? So if we don't get any sort of artifacts, we've just saved ourselves, I don't know, how many hours rendering this whole sequence with, really no work. Just changing a couple settings. So if you have really, really, really thick smoke, then you're going to want to use higher settings. Because, yeah. And I think next we're going to go to a later frame where all of the fire is kind of buried in the smoke. Because that's really where you get the prettiest looking renders, is where you've got the smoke being illuminated from the inside by the fire. I always love that. All right. So now let's take a better look at this. Doesn't look like we have any artifacts here. And if I go to image controls, horizontal, let's see what we got. So I am scrolling between the two images, and I actually am not noticing any difference at all between them. If I just switch, I seriously can't tell the difference. So we just saved ourselves a lot of time. So now let's go to a frame where there's a lot less fire. Something like a little more than 2 seconds in. Something like this. All right. Let's see what this render looks like. Another thing that's possible is that there are additional artifacts that are showing up, but adaptive sampling is getting rid of them. In which case, that doesn't really matter because adaptive sampling is getting rid of the artifacts. I think I've only experienced artifacts in the smoke once, and that was a really, really long time ago, probably in a, really archaic build of TFD compared to, what they have now. It was probably a couple years ago when I was playing around with this. So, like I said, you want to bring those settings down as low as you can. And in fact, one thing we might want to consider doing is actually bring the bring the thickness of the smoke up. So one thing I'm noticing that might be a problem is, see, you've got the fire here. It's pretty localized with, you've got some hot spots. And what I want to see is I want to see the smoke be pretty non-illuminated around the edges here and only illuminated around these hot spots. So I think the way to fix that is to bring the thickness of the smoke up. And if we have to bring our illumination settings up too, we can do that, but I don't think we have to. I think we're good. So I'm going to try doubling the thickness of the smoke and see how that changes how this looks. So as you've probably already noticed, this dialing in the settings for your fluid simulation requires a lot of test renders. And, you know, that's kind of always the case. So right now, I can already see that we're getting what we're looking for. So if you look closely at these two renders, you can see that this one is a lot more illuminated than this one, and then the illumination in this one is much, much more concentrated. So what I'm going to do is I'm just going to go ahead and abort this render, and I'm going to bring this thickness up even more. I'm going to bring that up to 70. So this is going to be really, really thick smoke. All right. And we are going to see how this looks. Now we, because I brought the thickness up so much, we might actually start running into artifacts. But we will cross that bridge when we come to it. And now I'm getting... There we go. I was worried my computer was going to seize up. I am now at 2.5 gigs available on my hard disk. I don't know how I'm going to free up space on my drive before I start rendering stuff. Alright, so I think this is what we want. So I'm going to go ahead and let this render, and we're going to compare these two and see how they look. I'm pretty sure this is exactly what we want. This is really good. Another thing, if you're doing like a big nuclear explosion or something, you're going to want really, really super thick smoke. Smaller scale explosions going to have smaller, lighter smoke. I really, really like this thick smoke look, so I'm going to do it whether or not it's actually realistic to whatever application I'd be doing for this. This is, you know, this is just me messing around. Yeah, so we're going to let this render. We're going to see what it looks like. I have great confidence that this is going to look dank. And it does look pretty dank. Upon zooming in, we can see we definitely have that thicker smoke look. And we've got kind of the smoke. I mean, the fire's kind of peeking in here. So I'm going to go to my image controls and we're going to compare these two. So you can definitely notice a difference here. Yeah. So one thing that I've noticed is if you look closely, you can sort of see a bit of a gap between the fire and the smoke. Now, unfortunately, there's not much we can do about this. But I know that there's one thing that we can do with our render to make it look a little bit better. So we're going to go over to illumination. We're going to set our fire brightness to 500. And then we're going to re-render. And this time I'm going to go to my camera and I'm going to turn my maximum samples down to 4 because I'm impatient. I don't want to, you know, all these test renders to take forever. I'm going to bring it back up when we actually render out this sequence. I probably should bring the resolution down too, but too late. It's going to take a bit of time for the frame to initialize because, like I said, I have 2 gigs left on my disk because I'm a terrible person who does terrible things to their computer. Now, another thing that we can do, if this doesn't give us what we want, we can go back to that clear smoke above parameter that I talked about, and we can use that to clear that smoke that's bothering us. But I kind of want to use that as a last resort because I feel like it's just faking this multiple scattering, because what the multiple scattering does is it uses the fire to illuminate the smoke from behind, and so you can actually see the fire through the smoke. So that's why I like to bring the fire brightness up. So that just brought the whole brightness for the fire up. So I think that this looks pretty good. I'm actually going to bring the thickness of the smoke back down to something a little more reasonable, like 40. Subgrid detail is a terrible, terrible thing. Just kidding. Subgrid detail is great. What subgrid detail does is it's an extra layer of detail beyond up-resing your simulation. And what it does is it adds sort of a turbulent displace to your render on the rendering side of things to make your to just add a little bit more fuzziness to your explosion. So we're gonna look at our preview here. I'm in the smoke section, and it's just adding a turbulent displace onto our thing. So this velocity displacement, I like it, but watch what happens when we use it on the fire. We set it to like 4, and let's turn the smoke off. We're gonna do it for the fire first, because I always use the same settings, but I do the fire first because I feel like the fire is easier to play with, easier to see what I'm doing. So you can sort of see what this is doing here, especially if we turn off the smoke. Velocity displacement looks at the velocity channel for your simulation, and it animates. So the recording crashed because I had too few gigabytes on my hard disk, so I had to delete some stuff. But anyway, I went ahead and fine-tuned these subgrid detail settings. Basically, my philosophy for this velocity displacement, I bring it up as high as it goes until you start to see this flattening at the top of the fluid. Once you start to see that, I don't bring it up anymore. Also, don't be afraid to have that be, you know, between 0 and 1. Having it be there a little bit is never bad. The noise intensity, I had that be sort of a bit bigger than the current voxel size, which is about, technically it's 8 millimeters, but it's actually 4 because I up-resed it, which is really tiny. And then my largest scale is 4 millimeters, because that's, you know, the size of the existing voxel. So there's no point in adding detail at a greater scale. And then the smallest scale is 2 millimeters. And in fact, I might actually bring the intensity down to like 10 millimeters, just because there's no point in having it, you know, be more conspicuous than that. You're just trying to add a little bit more, just that extra little bit of detail. So a couple of things to keep in mind when you are using subgrid details. The first thing is it's easy to make your thing look terrible when you use subgrid detail, and then the other thing to keep in mind is that it will bring up your multiple scattering simulation times tremendously. So if we do one more test render, I think we'll probably notice that the multiple scattering times are going to go up by quite a bit. So once again, the frame is taking a while to initialize. Unfortunately, that's how these things work. One bug, I'm pretty sure it's a bug that I noticed, is that when we simulated the upres, oh crap, I didn't turn smoke on, crap. When I simulated the upres, the intensity for everything went way down. So like in the non-upres version, the fire lasts a lot longer. Oh no, I don't want to resim. Gosh, no. I don't know if that's intentional, but I'm pretty sure it's a bug. So Yasha, if you're watching this, that is pretty sure that's a bug, or just something, you know, you need to adjust, or don't adjust, you know. So we're going to check this render, we're going to check one more thing, and then we're just going to, you know, render this bad boy out and see how it looks. And hope that my computer doesn't, you know, die in the middle of the night while this is rendering. So as opposed to taking like 10 seconds, multiple scattering is taking about a minute. That's still a minute per frame, which is like still less than before we optimized our multiple scattering settings. The other thing about multiple scattering is I think that we'd get a lot more contrasted stuff out of the smoke, like we were talking about before, if we brought our resolutions up. But I think that the faster render times is worth it, honestly. And this is really bad practice, but you can always add contrast in post. And also, this is just an example. You know, if I was using Octane to render this, and you know, I you know, simulated this out with my external Titan X GPU and all that, I'd probably you know, put a little more effort into having higher render settings. But you know, I just have, you know, a you know, 2012 i7 iMac that I'm doing all of this on. So I don't really have, you know, those options available to me. But we can definitely make this look good from where it is. Like, I can tell from this render that this is going to look really, really good. And so once we render this, we're going to see that there's a little bit more detail in the explosion. All right, so if we zoom in on this, you can see that there's a lot of subgrid detail going on here. In fact, we could probably stand to bring this up a little bit more, but I don't want to bring it up more because I really, really like how this looks, and I don't want to mess it up, and I also don't want to do another test render. So these are going to be our final settings, and I'm going to just check one more thing, and that is what the simulation looks like the very last frame. So all we're going to do is we're going to go to our viewport preview after this stupid OpenGL goes. We're going to go to our viewport preview. Can't talk. This is taking forever. I really shouldn't have simmed at such a high resolution. It looks beautiful, but just dealing with my system being so slow, what I need to do is I need to get a Thunderbolt SSD or just a Thunderbolt drive. I just need a Thunderbolt drive, and I can just have that be my Turbulence Thunderbolt drive, and I'll write all my caches to that. Like, you can get a 1 terabyte Thunderbolt drive for what, like $60? really cheap. It'll definitely be a worthwhile investment, because this is just ridiculous. Like, my poor computer is just... There we go. All right, so density, smoke shader. See what this looks like. It's pretty thin. It's thinned out. Very last thing we're going to do, we're going to set this, turn this off, and we're just going to frame our camera based on the container size. Okay. So we just want to frame our camera so that everything is in the frame. You want to frame your camera keeping in mind what your intention to use this footage for is. My intention to use this footage is, number one, just as a test example, because, you know, this is a tutorial. But my other purpose is, you know, if I wanted to, I could composite this. So I am shooting at 35 millimeters for my focal length, which is a pretty tight focal length, which will compress things a lot more. And so I want to shoot this so that I am maximizing my resolution. So this needs to be as close as it can without cutting anything out of the frame. And then I'm just going to delete my first keyframe here so that everything is at the same frame. And so with that... All right, so the final part of this tutorial is we are going to go ahead and do some post stuff to this explosion render, and we're gonna get our final product, and then maybe after that we can do some compositing or something, I don't know. So I'm gonna make this new composition, 24 frames per second. Duration is going to be 5 seconds, 24 frames per second, and it's gonna be 2560 by 1440, or 2.5K, which is what we rendered our thing at. So I'm gonna go ahead and bring our sequence in, and I actually I rendered this out. I rendered this out the up-resed version, but the up-res version actually gave me a bunch of errors, so I had to go down and delete my up-res. So all that, you know, effort I went to was all for nothing, but it doesn't matter because this is still pretty good. So one thing you want to do is you want to go to interpret footage, main, and you want to make sure you're assuming the frame rate that you want, which in this case is 24 frames per second. So let's always remember to do that. And we can see we've got our explosion here. So first thing we want to do is we want to change our workspace to 32 bits per channel. And then also let's add a gray solid. So if you watched Andrew Kramer, Video Copilot's explosive training tutorial, this is going to be really similar, but I do a couple of extra things and combine a couple of extra techniques that other people do, and I think that I can get a pretty good result from it. So the very first thing we're going to do is we're going to go into our explosion here, color correction, hue and saturation, and we're going to touch up these colors a bit so that we can get something better looking. Now, one thing to remember is people always work at different bit depths, and people always, you know, you're always going to have different render settings in your explosion. So no two are going to be the same. So you're going to have to fine tune this for every single explosion that you do, or any sort of fire and smoke simulation that you do. For this one, we can see that, you know, we set our fire to a really opaque setting. So the fire is really opaque. So that's going to come into play later. But let's start with the reds here. So let's go somewhere where the explosion starts to die down. And if you actually look at a picture of an actual explosion, so if I pull this up, you've got really vibrant colors here. You've got a lot of red, a lot more red than you think you would have, and then you've got a lot of yellow. So generally you want to have this orangish stuff, but you also want to have a lot of reds and yellows. Don't forget about those, don't neglect those. So the first thing that we're going to do is we're going to take this red and we're going to shift the hue over a bit to make it a bit deeper, a little more magenta, just by, say, -7 degrees, something really minor. See? And then we're also going to bring our saturation up to make it more vibrant. We're going to bring our lightness down. So already you can tell that's a pretty big difference. Okay? Second thing we're going to do is we're going to go to where the explosion is sort of stronger here. We're going to go to our yellows. We're going to bring our saturation down just a bit, but we're going to crank the lightness. Now, depending on what you did, you're going to want to fine tune your settings, and especially it depends on what look you're going for. But for this particular thing, I'm going to crank the lightness way up. You're probably not going to need this much. And then also, to get more of what we want, we're going to take our yellows and we're going to actually move this over a bit. And get that. So before, after. And then another thing we're going to do is we're going to shift the yellows over so that they're more yellow and they're less purple. This lightness I think is actually a bit too extreme, so I'm going to turn it down to there. So that's pretty good. All right, next thing we're going to do is we're going to add a tritone. Now I think Ben Watts actually came up with this, so kudos to him. This is a really cool idea. You set it to sort of a desaturated orangish kind of dusty color, all right? And you're going to start with the blend with original at 100% and bring it down until you get to a value that you like. So I like this. If we scroll through, you can see that this looks pretty good. So before, after. And so I think this is coming along nicely. We're kind of lowering the dynamic range of our fire here, which is kind of what we want. All right. Maybe bring this down a little more. Okay. Next thing we're going to do is we're going to add a glow. So that's what this solid is for. If you try and add your glows without a neutral solid color, you're going to get something really inaccurate. And also your glow settings are going to vary very, very much if you're not using 32 bits per channel. So let's set our glow threshold to about 80 for this one. Set our glow operation to screen. If you're using screen for 32 bits per channel, you want to be extremely careful because you can get problems like this. But if you're careful, you shouldn't run into any of that. Glow colors to A and B colors. Set our A color to a sort of bright orange like that, and then set our B color to sort of a red orange like this. All right, and we're going to actually increase our threshold a bit. All right, bring our glow intensity up, and then bring our glow radius out a bit, so you can sort of see what's going on here. Actually want to increase this even more. Now, if you increase this too much, then you start to get weird stuff going on, so don't do that. Nothing's uglier than too much glow, but just the right amount of glow really, really sells the effect. See? Let's take this, make it a little deeper red. Make this a little brighter. Increase the contrast between these two colors. All right. Let's actually bring this glow radius down a bit. And then bring our glow intensity down to like 0.8. Something really small. Something that you can't really notice unless you turn it off and compare the two. Alright. Next thing we're going to do is we're going to duplicate this layer. We're going to have a second glow. We're going to bring our glow threshold down even more, just so that's barely affecting the solid. Bring our glow intensity way down and our glow radius way up. And this is going to be a wider glow. And actually, let's take this glow threshold and bring it up to like 70. So this is what that looks like. So you can tell without the glow, with the glow, big, big difference. All right. Only got a couple of things left. Last thing is, remember when I said when we were simulating not to worry about the fact that this is dark in the beginning? Well, we're going to fix that now. What we're going to do is we are going to add an exposure effect to this explosion. We're going to put it on top of our hue and saturation. And so what I'm going to do, that I came up with this when I was doing that one test, find a frame where you think the explosion looks good. So I'm actually gonna edit this a bit. Okay, so I think this was pretty decent. Around here. Okay, set your exposure and gamma correction keyframes in the beginning. Crank the exposure to something like that, and then crank the gamma correction to like 2.5 or something. Alright, so it's just a white ball, and then it'll animate, so it'll start out really, really bright and then sort of fade into your explosion. Alright. And we can even make these F9 easy ease keyframes so that it's a little bit smoother. In fact, I think I'm going to move these out a bit more. Something like that. I like that. I like that a lot. And the trick here is you want to wash out the explosion, but not enough so that you lose this detail here. Alright? Very last thing we're going to do is I realized that you've already got those two layers of detail. You've got upresing and you've got subgrid detail. There's one more layer of detail you can add, and that is to add a turbulent displace to the layer. So go to distort, turbulent displace, stick it at the very, very top. Okay, you're going to want to set the size to the very smallest, which is going to be 2. All right, set the complexity all the way to 10, and then alt click the evolution tab and set it to time times 2000. All right, so that's just going to make a turbulent displacement map that's going to evolve through. So what that does is, if you look, this explosion here, turn it on and off, you can see that it's adding a little bit of roughness to the explosion, almost like what subgrid detail does, except this does it in After Effects to the existing render, so it's much, much faster. All right, so we're actually going to want to up our intensity here in the beginning, something like, I don't know, 90. Okay, and then once we get to a pretty stable place here, just get to the point where it starts to look bad, which is going to be about here, maybe a little bit farther, around here. All right, bring this amount down to 50. All right, or even 70. All right, and then bring it even further down, farther you go. So once this starts to cool off, then bring it down to 50. And then here with the smoke, I actually think you can keep it how it is. So now press U again to get to our keyframes. See our turbulent displace. Oh crap, I forgot to animate it. Shit. Alright. So like I said, 90. Always remember to click that stopwatch, kids. $70. $50. Press U to get here. Let's make these curves easy ease. And then let's space these out a little more so that we get something a lot more smooth. All right, and I actually lied. We're going to add one more thing, and that's just going to be a really simple contrast curve. So just do not overdo this. Do not overdo this. Very important to not overdo this. Okay. Let's go ahead and save this. I think I'm going to actually bring the lightness for this back up. And I like how this looks. I like it a lot. Especially the smoke at the end. I like how that looks. So now make a RAM preview and enjoy your handiwork.